we have a quotient of two functions, and we don't have quotient rule to evaluate this definite integral, so somehow we need to get rid of this fraction. So e raised to square root of x over square root of x, and the only thing we know as formula is antiderivative of ex or eu du is just eu plus c, because the derivative of exponential function eu is itself. Okay, so somehow this should look like that, because e raised to something, so this one should be u, okay, and 1 over square of dx, that should go to du. That's the only way we can use to find the antiderivative, since it involves exponential function e. So we want to let eu, so u equals square root of x, or you can say from the bottom that says u. With this substitution, at least the top looks like e raised to u. Okay, e raised to u. So we need to look for du. For we want to find the derivative, in fact differential. So du is what is the derivative of square root of x? It's like x raised to 1/2 xn. So n x n minus 1, half minus 1, which is negative 1/2. X raised to negative 1/2. Okay, negative 1/2 means put that on the bottom, so positive 1/2. That is in terms of x. So find the derivative of square root of x, you will get 1 over 2 square root of x dx. So the top matches with eu, and we have 1 over square root of x dx. Look, 1 over square root of dx. These two, we can multiply both sides by 2. So 2 du will be 1 over square root of x dx. Then this becomes, the top becomes now eu, and we have 1 over square root of x dx. Okay, 1, there is nothing, means we can always have 1 as a factor. 1 over square root of x dx, this is 1 over square root of x dx is 2 du. Okay, so we have e to the u times 2 du. This way we got rid of the fraction, and we can now use this formula. Okay, so with this substitution, then we get, okay, and we need to take care of these limits of integration. We can always find the indefinite integral, back substitute u, and evaluate upper limit minus lower limit, or we can take care of the limits now. Okay, look at the previous question. I showed you both methods, but taking care of limits is better. So let's take care of those limits now. So I want to do a little bit here. So these limits, let me get rid of this. Okay, so when x equals 0, because we are trying to convert in terms of u, we want to find what is the value of u. Okay, when x equals 0, u will be, so it's given from here, u is square root of 0. When x equals 0, u is 0. And when x is upper limit 4, then u will be, u equals square root of 4, square root of 4, which is 2. So these limits in terms of u will be 0 to 2. Then we get this integral 0 to 2 e to the u, that is what we assumed, and 1 over square root of x dx. 1 over square root of x dx is 2 du, so times 2 du. Then the integral is like this, and we can pull 2 outside, and that leaves definite integral of eu du from 0 to 2, and antiderivative of eu is just eu. 2 is outside, eu is just eu, and we want to evaluate from 0 to 2. 2 is already outside. Evaluate this function at the upper limit, evaluate this function at the lower limit. Okay, e, replace the variable u by 2 and 0. So e is 2 minus lower limit e to the 0, and e square is a number. Okay, don't go for decimal, it will be a decimal number, but e raised to 0 is 1. So let's simplify. 2 e square minus e to the 0 is 1, and this is the final answer.